This question is asking you to give the common name for these molecules, and this is going to be one of two functional groups where in Principles of Chemistry they tend to ask you for the common name. So this first one is an ether. And you know that you have an ether when you have an oxygen single bonded, and on each side you have a carbon. So an oxygen single bonded to two different carbon chains. The carbon chains can be anything, but it's an oxygen with a carbon on each side. That's how you know you have an ether. And we are going to use some of the nomenclature that we've used, the table at the right, but there is something slightly different going on when you give a common name as opposed to an IUPAC name. The IUPAC names follow very rigorously this table on the right. So we're going to borrow from that, but common names kind of have their own rules. Now, normally when you choose a backbone for an IUPAC name, the backbone is the longest carbon chain that you can find that includes the functional groups that you have. In this common name for this functional group, the common name for ethers, the oxygen all by itself is your backbone. And the name for that backbone is always ether. So the backbone name for every ether, when you give the common name, is ether. The carbon branches that are attached to it are named as branches. So to name those branches, you use the normal IUPAC naming scheme. So for example, this carbon chain on the right has 1, 2, 3 carbons. The prefix for 3 carbons is prop. And because it's a branch, immediately after that comes YL. The carbon chain on the left has 1, 2, 3 carbons. Again, the prefix is prop, and because it's a branch, again, immediately after that comes YL. So far we have a backbone called ether, and we have 2 branches, each of them propyl. Because those 2 branches are the same type of branch, they're both propyl branches, we can smush them together, put a prefix to say how many we smush together, and then you have to say what type of branch. So propyl, oops, let me just do that in gray. So propyl, so dipropyl. Now notice the branches didn't have to be given a number to say where they attach to the backbone, because the backbone is just one atom. So there's no ambiguity about where the backbone attaches. It has to attach to that one oxygen atom. So you take the backbone name and you put it in front, you take the branch name and you put it in front of the backbone, and the name for this would be dipropyl ether. Dipropyl ether is that molecule. How about with this one? Well, again, you would notice that you have an oxygen bonded to a carbon on each side. That's an ether. The backbone is the oxygen itself, and it's called ether. And the carbons coming off of it are going to be named as branches. And this is just the weird way of giving the common name, not the IUPAC name, the common name for ethers. So we name each of those carbons coming off the oxygen as branches. The one on the right has just 1 carbon. The prefix for 1 carbon is meth. And because it is a branch in this naming scheme, immediately after that comes YL. So we've got methyl there on the right. On the left, we have a ring, and anytime you have a ring, you need cyclo going before everything. Inside of that ring, we have 1, 2, 3, 4, 5, 6, 6 carbons, and so the prefix is going to be hex. And because it's a branch, immediately after that prefix comes YL. So we have cyclohexyl and we have methyl. Now, we have 2 branches. We know they both have to go in front of the backbone name, which is ether. But what order do they go in? They go in alphabetical order. And we're going to compare the C of cyclo with the M of methyl. C comes first, and so we will put the cyclohexyl in front of the methyl. Whoa. And the name for this, The name for this will be cyclohexyl methyl ether. And in this common naming scheme, there is a space in between each of the branches and the branches in the backbone.